Welcome to the meeting. Yay. Sorry about all the confusion.
Just sick. Oh, you're sick.
So,
Yep. Okay. I'll be right, I promise.
Okay, so no questions from this week's reading or stuff?
I don't have any questions. Yeah, I got it down, I think.
Okay. Should we start the quiz then?
Yeah, let's do
You guys
it.
already started?
Yeah,
Yep.
I finished it.
Yeah.
So
Oh, okay.
the first like 8 questions are super easy. So
When you're taking sample size of N5, what's the
do you get
Is
what
it
that's asking,
normal?
Amy?
what?
No.
No,
So
it's right skewed because it's not enough sample size.
yeah, the sample size isn't large enough, and so the population is going to be right skewed.
Okay.
Or skewed right.
So the next one's normal.
Uh huh.
That one's normal because the parent population is normal.
Uh huh.
Number 5.
Yep.
Normal again, right? Because
Yes.
it's 100.
For 6, yeah.
Okay.
6, yeah.
And it's 100 and it's normally distributed. So
Yes, they're okay. Thank you, Sue.
Oh, yeah. So number 7, the only one that's not checked, is there only one? The data drawn from the population that is right skewed and the sample size is small? Or are they all
yep.
right? Okay, so just the 3.
No, because if it's right skewed and the sample size is small, it's going to be skewed to the right, so it won't be normally distributed.
So we only do the normally disputed and the sample size is small, normally disputed and the sample size is large, and right skewed and the sample size is large.
Mm-hmm.
So I don't understand that. Okay. The 7. I put B.
For
But
which one?
I don't know
Well,
if that's correct.
Well, it says there's multiple answers.
Let's see.
Are there any other ones that would be normal?
Okay. Let me see. The last one?
Yep.
Yeah. And okay. So B, C, and D.
Not C.
But
So
A
A,
is,
B, and D.
Yeah.
yeah.
Do you know why it's A rather than C?
Yeah, I remember. Now I
Okay,
remember.
okay, cool.
Very well. Okay.
And then for 8, I think it's A.
I got D.
D?
Yeah, I got D as well.
Okay, I'm confused.
Because the central limit theorem has to do with the shape.
Okay, not the like I was reading about like the sample sizes and stuff. That's why I was okay.
I think. Let's see.
And 9, I got 10.
sorry, for number 10, 9. Did you guys do 9 yet?
Yeah.
Yeah.
You did 9? Okay, yeah.
Mine is 10.
Yeah.
And for 10, I got 1.
Mm-hmm.
Wait. You got 10 for 9?
Yeah.
Yes.
It's
So you
6 divided by the square root of 36?
no. For 9, you do
For 9.
Your sample mean is equal to mu, which is that weird looking U thing,
Uh-huh.
and that's 10.
Oh, okay. Oh, yeah. Okay. Got it. Thanks. And so, what'd you say 10 was? 6?
10 would be 1.
Why is it 1?
Okay. I have them mixed up.
So for 10, it's asking for the standard deviation of the distribution of the sample means. So the
Okay.
standard deviation that they give us up there is the standard deviation of the parent population. So to find, to find the standard deviation of the sample means, you have to take the standard deviation and divide it by the square root of the population.
Okay. Got it.
And that's 1. Okay.
And for 11, it is normal.
Yep, that's what I got.
Okay.
Right.
And so the last one would be central limit theorem.
Yeah, because it's the shape.
What, 12?
Yeah, B.
Right.
I got law of large numbers.
But it says,
think-
what would the shape be? And the shape has to do with,
The shape has to be with the limit theorem.
Regardless
yeah,
of
the
distribution of
central
population.
limit theorem describes what happens to the shape, and the law of larges describes what happens to the spread. I don't know.
Here, let me think about it real quick. I think you guys are right, actually, but the sample mean will typically be close to the population mean. If sample size is large, then the sample mean will typically be close to the population mean.
Okay, so it says, notice that this is very different from central limit theorem. The central limit theorem states that if the sample size is large, that bar X will be approximately normal. The law of large numbers states that the sample mean bar X will be close to the mean, or the weird U. Population.
Yeah.
Yeah. So, if
Yeah, I think it is central limit theorem. Sample size is sufficiently large.
yeah, I think that's what it is. Your quiz.
I just submitted it, and I got 100.
I submitted.
Cool.
Okay, was the
Nice
central limit.
work. Nice work, everyone.
Yay.
Submitted.
So,
Thank you all for being patient.
sorry, you're saying. So Thursday at 1:30? No, not 1:30.
2:30.
It's 1:30 my time, so 2:30.
Uh-huh.
Yes.
And
I will be in charge.
okay.
Yeah.
All right.
What did you
got
get for number 8? Wait, what did you get for number 8?
For 8,
it?
D.
For the bell-shaped data, right?
I did D.
It would be D.
D.
Yeah.
The sample size is large. The shape of the distribution means that they're approximately normal, because it's the shape.
Yeah.
It's the shape of the distribution that the central limit theorem affects.
Okay. Okay. I don't know why I ended up putting that one because I was like, okay, Christian, stop. Okay. All right. Well, if everyone's good.
Okay. Is that it?
Cool.
Got it.
I think, yeah. All
All right. We'll see you guys on Thursday.
right, sounds good.
I'll post this. All right. Bye.